The first step would be understanding the specific geographic location in terms of latitude and relationship to the sun. It's really important both in the energy profile of the building and energy and net zero strategies. Many people don't quite realize that keeping a building cool with proper insulation requires more energy than keeping it warm, even in northern latitudes. Passive solar gain is a tool, something you can really manipulate to your advantage, regardless of where you live.
Welcome to Mindful Businesses, Our Sustainable Home, and I'm your host, Vidya Iyer. In our podcast, we bring you businesses that are mindful in their practices and processes. A mindful business adopts and employs sustainable social, economic, and environmental practices. In our series, Our Sustainable Home, we talk about resources, options, and innovations in the residential construction industry. We delve into what is a sustainable home. May the goal be net zero, carbon positive, water or energy conservation. We provide viable solutions and options available in the market for our listeners who wish to live in a sustainable home. Today we have with us Jackson Wyatt, CEO of CABN, Net Zero Housing for Everyone. He joins us from Ontario, Canada. Welcome, Jackson.
Thank you. I'm really happy to be here and talk about sustainable housing.
Humans in the past, their homes were designed to be in sync with nature, their seasons, the sun patterns. We have moved away from such a lifestyle. How and when did that happen?
I believe it was based off of, and oftentimes just always the pressure point of the times. So whether it was access to food, transportation, so transfer to carts to cars, or just kind of living in various communities. But I also think that architects and builders have aspired to go back to tracking and understanding the energy profiles of buildings as well in a contrast. So from Frank Lloyd Wright's prairie houses, which allowed airflow, to understanding proper roof slopes based off of the precipitation that you receive. All of these things are actually an acknowledgement of the climate and the energy of a localized geography. I think now with the advantage of the technologies that we have, we can take that even further and truly make buildings that are taking into account all those energy profiles and regional and local constraints and make better buildings.
What are the technologies available for you now?
For us, my background is in advanced technology manufacturing. So the ability to prefabricate standardized home components in a controlled environment, and then the ability to ship them into remote areas that would not necessarily have access to that style of construction or those materials is one aspect of the technology. The other is my company, we utilize an advanced energy-informed design process. So it takes into account very accurately the concept of the solar azimuth, local precipitation conditions, weather conditions, latitude, climate orientation, so that we can actually derive an energy profile of the building over an annual basis, so that we can be specific in the amount of solar we put in the building or different windows we put on, so that it's accurate to the location. From a specific technology standpoint, obviously the advancement of window technology, solar module technology, insulative factors, particularly for us, we use mass timber, which is carbon sequestering, but also allows the building envelope to be scaled, manufactured, produced, but requires less of that internal structure for supports. So you can really deliver an efficient, insulated, with windows envelope to pretty much anywhere around the world.
So let's start from basics. I have a plot of land. How would you design it in terms of making it energy efficient, net zero, net positive? What would be the first step in that process?
The first step would be understanding the specific geographic location in terms of latitude and relationship to the sun. It's really important both in the obviously energy profile of the building, kind of with standard passive house strategies, and energy and net zero strategies, but also in relation to optimizing how much energy you can generate if you are, for us, if, for example, we have whole solar roof systems. So the ability to look at a site, understand where it is in relationship to the sun, the orientation of the building, then properly strategizing on the shade profiles is one of the most important things. I think many people don't quite realize that for the most part, actually in the future, keeping a building cool with proper insulation it requires more energy than keeping it warm, even in northern latitudes. So really understanding where your building is latitudinally in relation to the sun and the shade profiles being optimized for that is highly important. For us, it's really looking at, you want to have sun be able to get into and energy to be able to get into your building in the winter, and then be properly shaded in the summers.
Is that what they call passive solar gain?
Yes, exactly. So passive solar gain is a tool. It's actually like something you can really, really, manipulate to your advantage, regardless of where you live.
For instance,
if you are looking at where I'm in Ontario, basic rule of thumb is how far northern latitude you are, or southern from zero, should be generally the roof slope. And that's optimization for solar generation, but then also taking into consideration your shade profiles. So that, again, when you're thinking in the winter, you want the sun to be as a high azimuth, you want to cover your windows with shade, but in the winter, you want it to actually have energy to be able to enter into the home to heat it passively without having to use your heating systems.
So for instance, you would have more of the windows on your south wall, and that would be able to absorb heat in winter. Would that be an example?
In passive house, what you want to have is the windows to be a tool for energy in the home. In a northern latitude, that means you want primary windows to be on the southern side of the home so that you can choose based off of when you want heat to enter or energy to enter into the home, when you want it to happen. Northern facing windows end up just being a lower insulative factor that essentially isn't a tool anymore. It's just sort of an opening. Now, obviously, a really, really well insulated building is a box with no windows, but that also could increase how hot it heats up regardless of the season.
Okay, so now we have the windows which are positioned to optimize.
We use energy-informed design, but basically the whole system is sort of an energy conserved system. So if you're designing the windows, you want to have them as a tool so that they can be optimized for the energy.
So we have now this piece of land. We have analyzed how far it is from the equator. We have our energy slope, which is optimized for solar capture. And prior to that, what we need to do probably is to figure out or minimize the energy consumed in the house by proper enveloping. I feel solar should be the last frontier, if you want to say, in how we plan a sustainable house.
I think you're right. Yes. I think what all homes should be looking at a energy efficient envelope, a much higher minimum requirement than is currently standard. When you control all the variables for air infiltration, insulation, orientation, when you control all those variables and it's a high quality product and technology, then you look at the specifics to the geographic location. And that's where you're correct, where it's like basically with a high quality product or high quality home that's very, very efficient, then you can control the ins and outs of energy using the tools like the window placements and shade profiles.
So we have the R factors, which are how well your walls and your ceilings and your roofs are insulated. Then you have the windows with the U factors. So can you talk a little bit more about what is an optimal R factor, what it used to be in a traditional home? I'm talking homes which have insulation, not the homes which were built during the turn of the century in the 1900s, 1920s, 1930s. But later on, when they actually put insulation in the walls, how much R factor did those homes have? And what do you aspire your R factor to be?
You really want a consistent our factor, and it's an average between obviously what amount of windows that you have and the actual overall insulative factor of your walls, ceilings, and floors. Now, in the past, the minimum standard it floats depending on when the building was manufactured and insulated, but you're looking from R15 up to R30, usually as an average. Our exceeding of R40 is our minimum requirement to allow that controlled environment. What I think of as a better measurement in terms of efficiency of a building is something called EUI, or energy use intensity. And that's based off of, you take into account the insulation, the appliances, and you take into account your heating and cooling and your energy usage for the year. And it's through either a meters per squared or a foot squared. In Canada, that range is anywhere between 200 to 250 kilowatt hours per meter squared. And it is not a huge leap in efficiency or technology to achieve less than a use of 50 kilowatt hours per meter squared, which we've achieved. It's something that you can work towards with all the different inputs. And it also accommodates that passive solar heat gain that you can use as a tool to keep the buildings warmer in the winter instead of clicking on your heating mechanism.
So how have you achieved this 50 kilowatts per hour meter cube with your insulation? That is helping you, if I understand that correctly.
If you think about maintained system, by having intensive insulation and having high quality windows and doors and having reduced thermal bridging. So thermal bridging basically allows energy to transfer through either like a stud. You can keep that energy in the house or keep that energy outside of the house. So in the summer, where your temperature within your home was hopefully less than what it is outside, you want to maintain that system. And the way you do that is through that efficient envelope. And in the winter, when you want to maintain your system as warmer than the exterior, again, you want to maintain that envelope, maintain that energy profile. So by having a consistent and high efficient insulation, windows, doors, and minimizing thermal bridging, you use very little energy to maintain your comfort level. We measure sort of it at around 21 to 24 degrees centigrade so that you, again, use the least amount of energy possible per square foot or per square meter compared to other construction strategies.
But if a house is really tightly enveloped, how do you have airflow? How do you make sure that the air quality is good? There is no condensation. How do we do that balance?
That's usually the first thing that comes up. It's about management of the humidity, and as well as when you're transferring air in and out of the building, making sure that you don't lose the energy in that controlled system. You use a sequence of different technologies, energy recovery ventilators, heat recovery ventilators, depending on your location, all to manage that interior system to maintain that like 21 degrees centigrade without a transfer of energy in and out of the house, as well as managing your humidity and moisture content. So obviously you don't want excess, which is a big issue in northern areas, in First Nations, things like that, with mold issues, because there's no management in that regard.
So how much does this solution cost in terms of cost of construction and operation per square feet?
For CABN, we are focused with our prefabrication and using our energy-informed design to ensure that all the systems are consistent. We have a range between $290 a square foot to $350 a square foot for the complete system.
Is that Canadian?
That's Canadian. That comes with all of your mechanical systems, your windows and doors, the complete envelope, the solar module systems and energy storage systems to allow you to be net positive. It all comes within this one product. The reason for that is a few-fold. One is that when you change any one of those mechanical systems, or if you change a window profile, if you change the style of window, it will directly affect the energy use intensity, or the amount of energy required to power the building and maintain that thermal comfort all year round. And it also allows the systems to work seamlessly integrated together. And so that you know and have confidence that you're going to reach or exceed your net positive goals and have that energy storage and make sure that you have a healthy home.
So does Canada have incentives for the homeowners or the builders who build sustainable homes?
There are incentives, and some just related to mortgage rates. There are some for retrofits. For the most part, we look at larger project-based incentives. I'm looking at government incentives in that regard to build entire communities that are net zero or achieving attainable, affordable, and sustainable housing. On an individual basis in Canada, it's very unique to each province and not as wide sweeping. But I know that's where it's mostly focused on retrofits instead of new builds. We hope to work towards having the benefit to customers and to homeowners that if you want to build sustainably right off the bat, that you should be able to get some incentives for yourselves. But as it stands right now, there's not as much.
Which is contrast to what is offered in the United States right now. The government just passed the Inflation Recovery Act, which offers several incentives for homeowners or builders who wish to use solar, geothermal, and other sustainable features in building their home. So you said you have homes for about $290 or so per square feet. What do traditional homes in Canada cost?
If you're looking at a range for a custom home, usually the rule of thumb is around $300 a square foot. The land is a big point of variability. If you're looking at a custom home, you're starting at $300 a square foot, and then it goes up and up and up. And you can kind of, the sky's the limit in that regard. And that's for single family homes. Now, where there's such an incredible opportunity for access to attainable housing is, from our perspective, the cabins allow you to build in places that don't have current utilities set up, that wouldn't necessarily be a very, very costly piece of land or property, or in sort of remote or rural communities that have, again, a lot of expressed interest in people moving into the community. They have the land, but they maybe don't have the infrastructure available to establish these communities. And through cabin units, it allows you to establish a energy system and utility system for a network of 5, 8 buildings, 50 buildings, 80 buildings, all working in a network together. So the cost is reduced in that infrastructural development that is required for these more sort of rural communities.
In Canadian dollars, you're on par with a traditionally built home in terms of costs.
Yes, and where there's flexibility, obviously, is in the interiors, complete flexibility to kind of move around different items and rooms and put washrooms where you need to put them. The envelope is obviously very consistent. Because we used our prefabrication scaled approach, it reduces the cost significantly. It also reduces the assembly timelines at the site. So our buildings, either the 1-bedroom, 540 square foot, all the way up to the 4-bedroom, 3-bath, 1,850 square foot, take an average about 3 days to erect. So on the high side, it's about 5 days. On the low side, you're looking at about 2 days for that smaller unit. And with that, you reduce costs on site, you reduce risk for inclement weather, and you kind of reduce the invasiveness of building on site. This opens up a lot of flexibility in building in these various different places.
One of the goals that CABN has is affordable housing. How do you define affordable housing?
Affordable housing is, I'll use the government, a standard definition from the government, but the goal is to have your mortgage payments or your overhead costs for owning a home to be around or less than 30% of the income generated by the average individual of the area. And the thing is, affordability is such a complex definition because different communities have different average incomes, they have different needs, they have different requirements. So that our goal allows us to to fit within that definition in a place like, let's say, in Eastern Ontario, where we're building our show home. So it allows kind of that affordability index. There's also an aspect of affordability in relation to the initial costs of a building. So by having a smaller home unit that's 1-bedroom, 540 square foot, or a 2-bedroom, 750, that entry level point is reduced. So your initial down payment is reduced, your ongoing costs are reduced. And then there's a third aspect, which I think is often forgotten, but very, very relevant for the next 20 years of your life or 50 years of your life living in a home, is the ongoing energy and utility costs and the maintenance costs. So by building a better, more robust home, as well as reducing potentially your utility bills to zero, the example we use is our two-bedroom model, our Sonder model. According to Hydro One, which is in Ontario, the energy provider, it saves that occupant over the lifespan of the solar panels $65,000. So you're looking at just your utility bills per month is negligible, and you don't have to worry about something like that. You don't have to worry about those ongoing costs of being a homeowner.
You said you're able to erect it so quickly because you have prefab materials. Often prefab materials or prefab homes are considered inferior or less durable homes. How do you convince the people who can buy a custom home traditionally built and what they're used to, and they feel comfortable thinking that they'll be able to sell this home? And how do you convince them to buy a cabin home which is made of prefabricated materials?
Often when people think prefab, they think sort of a manufacturing line where you're making the home panels traditionally, stud panels, and then you're assembling the building in pieces. So like a half house or maybe even a full home. It's technically taking the traditional construction strategies and just doing them in a controlled environment. Whereas we've taken it further than that. Our goal is always to exceed minimum requirements. So we utilize mass timber, cross-laminated timber strategies. And where this technology was originally put into place to replace structural steel and concrete for multi-residential low-rise buildings. So the quality and the strength of it is beyond what is usually used in sort of single-family homes traditionally. It also allows the panels produced to have an extremely reduced amount of waste, because all you're doing is you have your standardized panel or our cabin components that are sized to fit within a standard shipping container, and just cutting out the reliefs for windows and doors in openings, and then placing those in them, and then they're insulated and then cladded to the exterior. So when attached together, they actually, with the fasteners, create a cohesive envelope that has been studied to actually have increased strength capacity up to 50% more stronger than traditional stick build. So when you're thinking about high wind conditions or inclement weather, which is more and more prevalent every day, having larger panels with stronger fastening points with less connection points is a stronger, more high quality building than just traditional methodologies of putting it together in a stick build.
What is CLT, cross-laminated timber? Could you elaborate more on what exactly? Is it like plywood or fiberboard?
So cross-laminated timber, what we use, it's FSC certified, so sustainably grown. It utilizes spruce, pine, and fir, which in Canada we have quite a bit of. Actually, a little known fact is that almost 90% of Canadian wood is FSC grown and distributed. But at some point in the chain of command, if a logger or somebody else isn't FSC certified, they lose the designation. But we make sure, obviously, it's all FSC certified. But the way cross-laminated timber works is it takes that spruce, pine, fir, and it takes the raw lumber and it shaves it off and then laminates it together in a crossed form. This increases the structural strength significantly and allows up to like 8-meter, 10-meter long panels to be constructed in one single piece. As a single piece, the vertical strength is incredible. And that's why it also, again, it was this technology designed to replace structural steel and concrete and remove that from the building process. It comes out and it's finished either on one side or both sides, so that you can actually have the raw material as part of the finish of your house if you so chose. And it's very, very robust, resilient, and has very high qualities in regards to fire resistance and fire mitigation. So all these things in conjunction make it a really strong material.
I would encourage all our listeners to go and take a look at the beautiful homes that are on the website. The website is CABN.co. They are so appealing. Just how they look, even the interiors, like you said, the walls can be the pretty light colored wood that I'm assuming they're all CLT made, the interior and exterior that your homes offer. They are really appealing, and I like the fact that you can use them in rural areas. You said that you can make these homes where there aren't support structures like drainage or water supply. How do you manage to give it to them?
Process for delivery allows us, we often work closely with the customer or the project and to get the site prepared, but we use a strategy called helical pile foundations. This allows a very diverse type of substrate or landing spot, I guess, for the buildings. So the big screws that go into the ground, and then the building and the foundation rests on top of them. From a waste and water strategy, it's very bespoke to the customer or to the developer or development. In that regard, if it's less than about 15 homes, we have our staff and everybody sitting here waiting, and we advise the proper waste and water strategy based on your needs. If you want to be completely off grid and you want to be using rainwater harvesting and you want to be using all these different items, we can facilitate that. Let's say you're building an ARU or a laneway home or a secondary suite and you want to grid tie in or have city power and water, we can do that as well. For anything in a larger development standard, we're working with a modular waste and water strategy, Nuterra, which allows actually the water processing to what comes out of the final potable water and the processed waste to be at zero nitrates, which is set and exceeds minimum standard requirements and pretty much across the board. But again, each site comes with its own interesting needs, and we address those as they come.
If we just think about water, you can do gray water harvesting. What is gray water harvesting?
So gray water harvesting can be a myriad of things, but it's either recycling and using what you've already created, or it's taking advantage of existing water sources or rainwater and basically allowing it to be used for secondary water usage. At this point, you wouldn't necessarily use it for potable water, but with a proper system and filtration in place, you can advance it to that point. But with gray water harvesting, you can again reuse some drainage and off-put. So you can reuse rainwater and a myriad of different other things to kind of up and compensate for your water usage. We do have some customers, for example, that are perfectly content and want to exclusively use rainwater, and then they actually bring in their water in a water tank that's for potability. And then we've got other customers that are looking for a full, complete system that does potable and gray water and the whole thing, and we kind of work with them on that.
So at the minimum, you can do rainwater harvesting and use it for your laundry, your toilets, your showers.
Exactly, yes. And again, it's all about kind of looking at the system as a whole. We're highly focused in the energy profile, but that's where our partners come in and we work with customers or developers to kind of see what's appropriate. Because, for example, some may have access to a water source or it's totally relevant to use city water. Maybe that's where they're placing them. So we kind of work with them in that regard.
The houses that you build are also homes, and a home has to be affordable, has to be comfortable in terms of the warmth and the coolness, the temperatures. And also, there's this new concept of spaces biophilic architecture. How do you bring that into your homes?
Biophilia was a big component of the design process of our units. If we were to say the three opposing but creative forces, so I think creativity and good design comes from constraints and opposition. The three major forces were ensuring that we could manufacture affordably to make an affordable product. The other would be the energy profile of the building using energy-informed design. And then the third was and is biophilia, and the idea of ensuring that there's a connection to nature and bringing the outdoors and the environment into the building and out of the building. There's a big focus on our units in the large window profiles, particularly on that southern face. That is in direct contrast with a perfectly insulated building. And that's where those 3 points of almost opposition come together and make a healthy, and from a biophilic perspective and a wellness and health perspective, a affordable in terms of manufacturing and a energy efficient, sustainable home in terms of the energy profile. That's how they all come together. Our focus was an open concept, allowing higher ceilings to allowing larger window profiles, opening up the home, also emphasizing the shade profiles to the exterior so that the deck or the exterior space is a seamless transition into the home. With the utilization of the seasons, you can actually have the center profile fireplace is surrounded by deck and living room. So when you're using the space, you're in and out, you're through, and there's no kind of beginning and end when you're entering into the exterior world or going back home to kind of nestle up and watch TV.
Sustainable home usually doesn't have a fireplace because you'd either be burning wood or gas. What kind of a fireplace do your homes have?
So we have the option for these high performance heat embracing stoves, wood burning stoves. Pellet is an option as well. So we're looking at basically the accessibility of different people and what they're really truly getting out. And I think this is actually where that compromise and that flex between biophilia and the experience and the living in a home, as well as the energy profile of a home. So the wood burning stove and the ability to understand your consumption of wood, to engage with the heating mechanism of your home on your own terms is an important part in terms of the experience of living in that home. The overall inception of CABN was very derived in the book Walled In by Thoreau, and these ideas of less is more in a way that you in connecting with the environment and connecting with your inputs and your outputs for your home. So although the technology takes a lot of the hidden energy management into account, the wood burning stove directly is a human engagement into that energy control in your home. In general, it's an atmospheric device to truly kind of make living in these more remote areas or living in a shaded glen or wherever, or by the beach, where have you, just that much more elevated.
Are you an architect? You mentioned that you were into automation and manufacturing. So do you have a background in architecture or process engineering?
My background was in industrial design and product design. I did derive actually from architecture, but in my previous company and a life ago, our goal was to replace all single-use plastics with compostable products. We were very successful in that regard. And what we found that the ability to make massive changes in terms of sustainability and help people change their behavior is to the ability to basically make compostable products the same price as plastic products. And the way you do that is through an advanced manufacturing approach. And essentially, if you want to compete with a plastic fork, you need to make 1 billion compostable forks. So that was our pursuit, which we achieved. And it allowed us to displace all these single-use plastics in the world. Taking those lessons, you knew that basically passive house and sustainable building, it seemed at the time, was only for a select few individuals that could afford it. So how do we approach this in a way that makes it attainable for more people? Well, let's take an advanced manufacturing approach. Let's take a whole system approach from end to end, from the componentization to the assembly process with shipping involved as well. Look at it as a whole system to make sustainable building attainable, and not just for somebody who can afford $1 million passive house. It's about looking at how we can make it more widely available to more people.
You almost want to be the IKEA of passive house.
Yeah, in a reductive way, I would take that as an honor. Where we differ is in the control systems and the longevity of the system. So I found success exceeding compostability standards, exceeding energy goals for Canada by 10, 15 years in our current buildings, by exceeding window performance that our windows currently that we use exceed most, if not all, that are mass produced in North America. So we've set our own personal standard at CABN to be the leader so that our buildings will be there 80 years from now. If they just so happen that by doing this through a scaled manufacturing approach, we can deliver them at a lower cost.
So how did you get funding for your company?
So the funding for my company, I'm very fortunate that after selling my previous company, it allowed me the flexibility to follow what I thought was right and what needed to be done. So I funded the initial setup of CABN, as well as seeded our nonprofit CABN Co-Foundation, which believes that housing is a human right, and it should be not just for a geographic constraints, but it should be available to all at a reasonable cost. That was all self-funded by me. Now we're in this phase of massive growth, and we've had support from a significant amount of granting bodies and some newer strategic investors. But we're constantly just looking at, we're just being so well received in terms of the public and homeowners wanting to have a cabin. It's starting to really it's taken off.
So how many homes have you built up till now?
So we're building our first home, a show home in Eastern Ontario. And then we've got our set of customers coming through all across North America. We have over 2,500 people looking to kind of purchase cabin units, and they're from all different walks of life in different areas and different geographic regions. So it's really this kind of really beautiful influx of people looking to build sustainably. So it's really exciting right now.
The windows are a very, very crucial component of this enveloping. Do you guys make your own windows? How do you optimize the thermal factors in the windows with the insulation and the design?
We designed our building using that energy-informed design, setting our own standards for thermal properties, glazing, placement based on orientation to the sun, all in advance of the windows being created. So we had such a high standard in our window performance, in its U factor, in its glazing, and its insulation, that we had to actually go overseas into Europe to achieve our quality of window and be able to do it at a scale to service our customers. It's nothing within that we could find within North America really serviced what our envelope needed to have to make sure that we could hit our minimum requirements of energy conservation. So that's what we've done, and it's been very successful for us. But it's one of the few things that is not continental North America or in Canada, because we are very proudly Canadian made and looked at always trying to be within Canada for most everything. But again, with the technology, trying to be at the very forefront, that's one of the finer details that we had to go into Europe.
And it's all about these balances that we have to make in the choices. So to achieve the energy levels, energy conservation levels that you want, you may have to break the norm of going overseas to pick a product till the technology of windows in North America catches up with the ones that are there in Europe, specifically Germany and Poland.
Exactly. And I think great design is looking at where consistently and proven technologies in the last small period of time are working exceptionally well, regardless of geographic location, integrating them all into one system, and then demonstrating to the North American market that these metrics of net zero and sustainability are easily achieved with the combination of these systems, with these build strategies, with these solar modules, with this insulated factor windows, all these combined, we can excessively achieve all of our 2050 goals for housing if we bring it all together into one system. And that's what we've done at CABN.
And hopefully the North American manufacturers will see the demand for these because of the imports and start offering those products and technologies to home builders and homeowners in North America.
Yeah, I agree. I think sometimes it takes, and it's too self-promoting, but sometimes it takes a company or a customer base to show that this is a need or an incredible want. And I would expect, or I would hope, that any missing pieces that the North American manufacturers are kind of waiting in the wings to figure out if it's a viable product line, they'll realize, 100% it is. Let's start producing better windows, the higher insulative factor windows, different kind of glazing profiles, because it's going to be sweeping across most, hopefully, new builds.
How are your homes powered? Do you use geothermal energy?
Our homes use primarily with solar modules and solar energy strategies. But when you're looking at a network of cabin homes, our team and my team of engineers and scientists, everybody's a lot smarter than I am. But anyway, coming in, we look at a larger strategy that does include geothermal, also like borehole energy storage strategies. So using both sides of geothermal complementarily. So that's, again, where it comes down to this community we're working on in Eastern Ontario. It's starting with a phase of about 67 units, and we implement all the strategies in managing that energy profile of the community at large, since the buildings themselves act in a network. So they generate excess energy with their solar roof systems, they utilize geothermal, and they utilize large-scale energy storage strategies related to the specific, where they are. So we do have one customer right now that's actually implementing a geothermal strategy in addition to the solar strategy as a complementary system. system, and it's looking really, really wonderful how it's setting up.
So you actually also need energy for the fuel pumps, which work in conjunction with the geothermal. And those will be now, in this particular instance, powered by the solar.
Yes, I think it's not a one silver bullet, one shot deal. When integrated and complementing each other, these different strategies are almost, they work better. They obviously work as their own sets of redundancies. And then they also work in terms of a seasonality of the buildings. In January and February, there tends to be, well, where we are in Buffalo or Ontario, there tends to be a little bit of snow and shorter sun periods. So having complementary strategies is always a huge advantage. And then also from an energy storage standpoint on a larger systems, having borehole energy storage is a huge, huge added bonus with obviously the individual battery storage.
So wishing you all the best, Jackson. Thank you for coming on Mindful Businesses.
Thank you so much for having me. It was great.
We were talking with Jackson Wyatt of CABN on Mindful Businesses. We'd love to hear from you. Send us a voice note with your questions or comments to info@mindfulbusinessespodcast.com. Subscribe, rate, and review us. If you learned a thing or two from this episode, share it with one friend. We recorded this podcast in Buffalo, New York. Theme music was composed by Tatum Gale. Our marketing assistant is Roseanne Korean. Our advisors are Jim Stone and Anupama Pasricha. This is Vidya Iyer with Mindful Businesses.